Now that we've introduced electricity and its properties, we could certainly talk about electrical components and circuits, and even explain how an old TV, a radio, and speakers work. However, we want to start programming computers, so the main electrical device we're going to focus on this week is the processor. The processor is what makes a computer unique from the other devices shown. The CPU, or Central Processing Unit, is to a computer as the brain is to a living animal. It makes calculations, decisions, and is essential to almost all devices you use on a regular basis. So what are the digital signals a computer uses, and how are these signals different from what radios and speakers use? Analog technologies utilize variable electrical signals in the form of changing voltage. Shown in the graph is a voltage or electrical potential changing in time. This variable voltage is called an analog signal. A digital signal is different because while the voltage is still changing, it can only be on at a specific value or off entirely. In a sense, a digital signal can be thought of as only on or off, yes or no, true or false, or most commonly referred to as 1 or 0. These voltage graphs may not make sense right away, but you will gain more understanding as you work through the lesson, so don't worry. As you will see throughout the camp, we live in an analog world. The temperature in the room doesn't go up in steps of 1 degree Fahrenheit, but rather its changes are smooth, like this graph. In order to work with the outside world, computers must have a way from converting analog signals to digital ones so it can understand the signal. This process is done using an analog to digital converter, or ADC. These devices are very sophisticated and will not delve into the specific details. However, the general idea is that an analog signal can be divided into little chunks called samples. Each sample may have a different analog value to which a digital value is assigned. Remember that digital information takes the form of ones and zeros, so really what the ADC does is turn an analog signal into ones and zeros that a computer can understand. Alright, just a few more things about computers before we can begin programming. First, you should note that the device that led to the computer revolution, making all of the digital technology possible, is called a transistor. Millions of transistors are printed inside a single processor and enable computers to manipulate the digital information using transistor-enabled logic, which we won't really get into this week. However, the use of input and output pins will be used extensively this week. These pins stem out from the processor and enable us to send and receive signals to and from the processor. Depending on which pin is used, an analog or digital signal can be sent or received between the processor. More on this later. Perhaps the coolest thing about a processor is that it can be programmed. Programs can be in the processor itself or in external memory. Programs tell the processor what to do when it receives a signal. For example, when you play on a smartphone, a signal is sent to the processor notifying it that the screen was touched, and the processor may respond by opening up an app or sending a text or whatever you told it to do. Programming is done using a programming language. There are many kinds of languages, and some are used when programming specific processors or software. In our case, we will be using C++, the Arduino's processor. Furthermore, we will begin writing using the C++ language in the Arduino's IDE. The IDE, or Integrated Development Environment, is basically a fancy WordPad that allows us to write and send programs to a processor. However, the program we write must first be compiled before it is sent to the processor, and this is often done for you by the IDE. When compiled, the written computer program is converted into digital instructions, ones and zeros basically, that are sent to and stored inside the processor. Here's a flowchart of the process of writing, compiling, and uploading a program to a processor. With a program stored in its memory, a processor or computer is able to respond to inputs and send outputs according to the instructions we have specified in the program we wrote, compiled, and uploaded. If you haven't already guessed, you will be programming your own processor called the Arduino Uno R3, well, a version of it called the Redboard. We will work with the Arduino IDE, which allows us to write and load programs to the Arduino's processor. Finally, it's the moment you've all been waiting for. Go on to the next video to begin working with your Arduino.